Hey, hello, and welcome to the show. It's time for John Park's Product Pick of the Week. It's me, I'm John Park. We call this JP's Product Pick of the Week. That sounded weird when I said my whole name like that. Is that weird to you? And I am excited because we have a cool product pick this week. And I'm glad to see we've got some people over here in the YouTube chat as well as the Discord chat. That there is the YouTube chat. That one there is the Discord chat. If you're watching over on Twitch or Periscope or LinkedIn Live or any of these other places and you're wondering where all the chatting is happening, head to our Discord. The Discord is adafruit.it/Discord. You'll get an instant invite and then you can jump in to the live broadcast chat channel. And we're streaming. We've also got some chatters over there in YouTube. And I am excited to, I don't want to doom it, so I'm going to knock wood. But I may have figured out a setting that may help some of the bandwidth streaming health here of the show. So I probably just cursed it and doomed it, and it'll just buffer right now. But let's see. We'll cross fingers. Let me grab a sip of water here. Oh, yeah. Start crunching ice, too. All right, so let's get to it then. I think, oh yeah, that's right. Doctor says I think Periscope shut down. I think they've actually switched it to a Twitter. It was owned by Twitter before, and now it's a different streaming thing on Twitter. I think. I'm not certain about that. So let's get on with the show. First of all, I want to tell you that if you want to head over to the product pick page, and spoiler alert, you're going to know what it is, but if you head to this URL or go to this QR code here, you're going to find that we have a 50% off discount on the product pick this week, and it is a really cool one. But before I go any further, I'd love to have Lady Ada do a little intro to it. So let's jump back in time to the new product pick when this came out. Take it away, Lady Ada.
This is a toggle push button for fairly high voltages and high currents. So this allows you to push on, push off a power supply, 3 to 14 volts, up to 3 amps. So it's pretty beefy, but I want to make it also small enough that you could fit on a breadboard. It comes with a 12 millimeter tactile button that snaps in, but you can also put your own push button in. But yeah, you press once to turn on, press once to turn it off. And there's also an off kill switch. So when that off pin, which is the 4th pin down, is connected to a high voltage, like pretty much any voltage above 1 volt, it'll automatically kill the power. So it's a way for projects to turn themselves off, which you can't do with a mechanical on-off switch. So the two benefits are, you know, it's compact, it's simple operation, and you can have a kill switch, so you can force it off. If you have a mechanical switch, you can't do that. The trade-off is, however, that it uses a pass FET to turn the power on and off. So there's no air isolation, which for some people, they need to have an air isolation. It needs to be completely isolated. This doesn't supply that. If the output is higher than the input, the body diode of the FET will turn on, and so you'll get back leakage. So that's kind of rare, but if you have a project that has something like that, not a good idea either to use something like this. It's limited in voltage. You can only use it from 3 volts to 14 volts. Actually, it works down to 2 volts. But the spec for the NAND gate that I use is 3 to 14. So I'd say 3 to 14. And the pass spec can do 3 amps. You can actually maybe do a little bit more, but 14 volts and 3 amps is at the max. Other than that, it starts heating up quite a bit. So I push to turn it off, and the camera freaks out. And then I can push to turn on. You can see over here there's a red LED that turns on. I added a red LED so you know when it's powered, which is kind of nice. And then this is that kill line. So if I touch this to here, it automatically kills. And then I have to press again to turn it back on. So you can turn it on by pressing the button, turn it off by pressing the button, or turn it off by raising the off or kill line high. So it's kind of an easy way to add a pretty intense power controlling switch to a project. If you want an elegant push button or you want it to be on your breadboard, it's nice and small and kind of handy. I like the kill switch because for some projects that you want to turn itself off, it has that ability. And it's all analog, so it's pretty simple. And it doesn't use a lot of current, so the quiescent current is like 0.5 microamps, maybe even less. This is the max. According to the data sheet, the max is 0.5 microamps. So you can use this for a battery-powered project.
All right, well, that's convincing me enough to want to go grab one out of my mystery cabinet of wonder drawers and then do a demo. So hang on while I go grab one. Yeah, I don't know what that was, but I know what this is. It is the product pick of the week, and it is the, what is its name? The push button power switch breakout. That's right, the product pick of the week this week is the push button power switch breakout. This is an analog latching power switch that allows you to cut power or turn on power to your project at the push of a button. You just press it once with a momentary button. It then latches the FET on here open so that you can power the project, and then you can click it again later to turn the thing off. Just cuts the power, and it's got some pretty cool features to it. So first of all, let me switch to a down shooter here. I'll move this out of the way for a second. I'll show you a couple cool features of this. So there's the board. It has some nice pins, header pins that you can solder, or pads that you can solder header pins onto to put onto your breadboard or onto a perma-proto. You only need to use one side of these. These are redundant just for sort of mechanical stability on a breadboard. You'll also see that you can pull off this switch. It does not come soldered on. It's just kind of pressed into there. And that means you can solder on your own power switch. So you could use an arcade button, for example, or any other momentary button that you like in order to adjust where the power switch is on your project. So this could be deep inside, and you could have a panel-mounted button if you like. I've also noticed that some of the tactile switches we sell that have these cool colored caps are a perfect fit for these, as long as you trim off. There's some little pegs on the bottom, plastic pegs I trimmed off. But now you can have different colored caps, and we sell little multicolored caps to go on these particular switches. So that'll work pretty well too. So let's jump over to the product page for a second, and then I'm going to do a demo. So here, if you have a look, this is the Adafruit push button power switch breakout. You see right now we've got them 50% off, so $2.98 if you want to get one or get up to 10 of them. And it describes the particulars of it, including my favorite feature, and one of the reasons I wanted to show this is this kill switch. It says there's a fourth kill pin, which you can use to turn off the load or keep it off even if the button is pressed. And this kill switch is a little secret sauce for having projects that need to be energy efficient. So you have a project with a battery, you want to be able to press it, have it do something, and then have it turn itself off until the next time you come by. You don't have to screw around with any sort of low power watchdog timers and things like that. You can just have the thing after some task has been completed or after some amount of time, the microcontroller can essentially cut its own power, which is pretty cool. So let's jump to my demo. Here I've got the push button power switch, and you can see I'm running power to it, which is coming from a battery pack. I've got a little AAA battery pack here that's going onto the rails. So I'm getting ground and power to the switch. Then the switch is sending its own out pin. You can see there the angle's a little funny, but the one that's marked out, that's heading through a diode over to I believe the 5 volt on this Cutie Pie, yeah. Then the Cutie Pie is going to be able to blink this big LED here, as well as its own little NeoPixel that's built on there. And the green pin, or the green wire that you see here, this is how I'm going to use that kill pin, which means if I send this A1 output to essentially a digital high, it means I'm going to be giving it 3 volts. Anything over 1 volt will enable that kill switch, which turns the thing off. So here's what happens when I fire this up. It's going to turn on, go steady, green light on the board, blink that LED, and then shut itself down after it turns red. And you can see the LED under the power switch also turned off. So that's a way that you can tell. When it's providing power, it's lit red under the power switch pin. And now my program runs through its course, it blinks its light, and then it's going to turn itself off, and you know it's off because that red light went off under here. Which is really cool. This could be something like, let's say, an infrared that you need to send some little infrared beacon to do something. Maybe you've programmed something to help someone with some automation tasks around the home, and you want to use some infrared blinking, but you want it to be battery powered, and you don't want to have to put new batteries in it all the time because it's run down. This is going to just sip power, barely use any power to run its little action, and then turn itself off and draw almost no current at that point. So I think that's a pretty cool demo of using that. If we didn't have that, we could just turn it on and off if we weren't using that kill switch. You can see here it'll turn itself on, it'll start doing its thing. Before it finishes, I'll turn it off. So I'll sneak in there and turn it off. So it still works as click once on, click once off. But my favorite part is that little kill pin right there. So it's going to blink, 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 and then shut down. So that's a really neat feature of this thing. I used this in a project I built, a sort of little robotic face that was meant for an art gallery, and it was interactive. People were able to come up and touch it, but it was battery powered. So for it to last a long time, when it was pressed, it would open up the face with little servo motors and then close and then turn itself off by using this very switch. So a really, really neat one. Let's see, what else? Someone asked about powering a Pi. I wouldn't use this for, yeah, Susan asks, here, let me bring up the chat here. In Discord, is this product okay to power on and off a Raspberry Pi project such as Octoprint if I also add a shutdown now button that I push first? Yeah, that's a great way to put it. Yeah, Susan. So if you have a button that does the safe shutdown of the Raspberry Pi as far as the operating system is concerned, that will not shut off the Raspberry Pi itself, right? So you want to cut the power to it if it's battery power. Then you could use a pin to send a command to this. I think your trick with that would be the timing of the shutdown followed by that 1 volt. So you might need to play around with having a microcontroller involved, perhaps, that does a little timeout after the shutdown command. But it's a good question. If anyone knows, anyone in the chat has used something like this to be part of a safe shutdown, I'd love to know, because yeah, that's an issue with the Raspberry Pis. You really want to run a safe shutdown first and then the power shutdown. Let's see, what else? James Foe says there's a nice tutorial on wiring a switch to the Pi pins somewhere. Looking. Okay, good. So that might show up in the chat. Yeah, same question, Eric Osterley. Will this work on a Pi to trigger orderly shutdown? This does not have a general purpose I/O pin on it, so I don't think you could send a command followed by receiving the command. That would be pretty neat. But I think you could do it if you added a microcontroller to it. So if a button on the microcontroller started the safe shutdown, and then the microcontroller sent the command to this power switch pin, you might be able to do that. All right, so, but yeah, I will say that's nothing I've tried with the Raspberry Pi, but I will say it works great for microcontroller projects. I think that's really what it's best for, what it's intended for. And I think that's it. Any other questions? Let me see. Suggestions, questions. That was the main one. Let's see. Oh yeah, so this is actually a really nice suggestion from Doctor in the chat. If you have a LiPo cell, you can have it turn itself off if the battery gets too low, right? So we can monitor, with most of these microcontroller projects, we can monitor the power of a battery, the voltage level of it. So you may be able to watch that and trigger a shutdown before battery completely ends itself. All right. Well, I think that's going to do it. So thanks for stopping by. Remember, if you head to that URL right there, that's going to get you 50% off of the product right now. That's where it lives. And let's see if we still have them in stock. We do. So yeah, you can grab up to 10 of those at this discounted price. You get the little board. You get some header pins for it. You get the tactile switch. It's a nice tactile switch. And then it's up to you how you want to wire that. You can wire directly to it, wire a switch to it, or go add the header pins and put it right into a breadboard or permaproto. That'll work really well. So that's going to do it. I am going to attach something to hang it from. I keep forgetting to grab a hanger. I'm out of those little, I think I'm out of those little Lego compatible hangers I printed. Let's see, will this one work? No, that's not going to work at all. All right, we're gonna do my favorite trick, which is hang it with a component. Got a big capacitor sitting here. So that's going to be our hanger. All right, remind me next week. So that's going to do it. That is my product pick of the week this week. Product pick of the week is the push-button power breakout switch. And if you put that in your cart, you'll want to check out pretty soon. The discount will only apply during this show, and behind the scenes, we have people who will change that price back pretty soon afterwards. So go ahead and check out with that in your cart if you've got one. And that's going to do it. So thanks so much for stopping by. This has been another JP's Product Pick of the Week. I'm John Park for Adafruit Industries, and I will see you next time. Bye-bye.